1939, J. Oppenheimer and Harlow Snyder predicted the formation of black holes by the collapse of stars. But how did this happen? Think about a star. A star's fuel is nuclear fusion and forms elements for producing energy to overcome gravity. It starts with hydrogen, proceeds with helium, then carbon, neon, oxygen, silicon, and iron. As this occurs, the star becomes more massive. When a star produces iron, nuclear fusion stops, and there's no force to overcome gravity. The star collapses into a single point, producing a supernova. If the star cores 3 times the sun's mass, it creates a black hole. The mass condenses it to a point with infinite density known as the singularity. The surrounding of this is the Schwarzschild radius, described by Carl Schwarzschild. An object needs an escape velocity higher than the speed of light to escape this region. In other words, you must travel faster than the speed of light, which is impossible. This is why light can escape a black hole. The boundary between a black hole and space is the event horizon. The black hole will only swallow an object if it crosses this border. How would that look? Imagine your friend falling into a black hole. Really, it would appear to freeze in time. Why? In 1915, Albert Einstein described space and time as one into a fabric called spacetime. Objects on top of this fabric warp space and time, causing gravity and variations in time. Now, take one string for spacetime and put a dot on it. Each dot represents an hour to reach the endpoint. In the first string, it takes 10 hours to reach the end. Now, place an object on top of it. It takes more hours to reach the sides after the string is stretched by the object's mass. Since black holes are very dense, the warp in spacetime is infinite, taking forever for someone to fall. But if you're falling, you're rushed up near the speed of light until you die from spaghettification. The parts from your body closer to the black hole will stretch, tearing your atoms apart because of the gravitational pull. Now, black holes can die too from a very slow process called Hawking radiation. Particles can release energy when annihilating each other, but at the event horizon this doesn't occur since one of the particles escapes and the other one doesn't, making a black hole lose energy. But have you ever wondered why a black hole is significant? Well, scientists suggest that there's a supermassive black hole at the center of every galaxy. Studying these objects can reveal how galaxies form. Moreover, the Event Horizon Telescope took the first picture of a black hole in 2019 using a method called aperture synthesis, also used in medicine. Science is more than wondering about the universe, but applying this curiosity to solve issues, and thus making the world a better place to live.